Alright, so this video we will be discussing paper 1-3 for May-June 2025. Okay, let's have a look for the first question. There's a curve with this equation, yeah? Right, then they want us to find the equation of tangent to the curve at this point, and then give your answer in the form of y equals to mx plus c. Right, let us talk about the equation of tangent. When you want to find the equation of tangent, right, every time when you want to form any equation of a straight line, you need two important information. The first one is the gradient of tangent, the gradient of the line. So for this case, we want to have gradient of tangent, where the gradient of tangent, you can get it from the dy dx. And the second information that we need is the passing point. And basically for passing point, we already have the passing point here. It is given in the question, this one. They are interested for the equation of tangent at this particular passing point. Right? So now we already have this information. Therefore, we just need to continue to figure out what is the value for dy dx first. Right, so I'm having the equation here. I write out in the x power n form so that it is easier for me to differentiate it later. Alright, let's differentiate the equation. So differentiate 1, you get dy dx. Differentiate 2x. X is having power 1, right? Put the power in front, copy the x power minus 1 becomes 0. So basically you're having the 2 only, right? Then after that, you're having 12. Focus on the differentiation of x power negative 2. Power you put in front, copy the x power minus 1, become negative 3. Try to simplify your expression here. You'll be having negative 24 over x power 3. And this is your dy dx. To get the gradient of tangent, I need the value for dy dx. So let's see what should we substitute for the value of the x here. Since we are interested for the passing point, the equation of tangent at this passing point, right? So you can see that our passing point here for the x coordinate is actually the negative 2, which means you have to substitute negative 2 into your calculation part here. Substitute negative 2 power 3. You'll be having negative 8. Simplify it. So 24 divided by 8, you get a 3, right? Then negative and negative become positive. And the gradient of the tangent is a 5. So you already get the gradient of tangent. You also have the passing point. We can get the equation of tangent now. What is the general formula to form any linear equation? There are a few ways. You can use y minus y1 equals to mx minus x1. Or you can use y equals to mx plus c. Find the c first, then rewrite the equation again. So for me, I usually use the y minus y1. So y minus y1, my passing point is the negative 1, equals to m x minus x1. So what's the m? M is a 5. Then x minus x1. So your x1 is negative 2. Okay, just try to simplify it. You are having 5x, then plus 10, okay, then minus 1. And if you try to simplify this equation by right, you'll be having y equals to 5x plus 9. Okay, so we are putting our answer in the form that is requested by the question. Alright, so this is how we solve question number 1. Let's discuss question number 2. We are having the first two terms of a geometric progression. I think this is one of the important keywords. So there are first two terms here, a and also ar squared, where the theta is angle such that theta is between 0 until pi over 6. Given that the sum to infinity of the progression is half, find the value of theta. Give your answer in the form of sine inverse k. Right? Okay, then let's have a look. In general, what is the geometric progression? What is the general formula for geometric progression here? Okay, so first of all, you need to know that the end term. Actually, we don't need the end term here. Basically, we need the common ratio. How can you get the common ratio in a geometric progression? You can use T n divided by T n minus 1. That means you have used the later term, divide the previous term. Or to be understand in the easier way, you can take T2 divided by T1. So second term divided by the first term and so on. Alright? And we are having the first term, this is T1. We are having the T2 here. Therefore, we can find out the R in terms of the theta. Okay? So let's start. Yeah, before that, let's continue to have a look for the information here. Sum to infinity. What is the general formula for sum to infinity of a geometric progression? The general formula will be A over 1 minus R. And you need to know that the A basically is the first term, yeah? Right. Okay, I think we can start now. First of all, I want to find the ratio first, the common ratio. So I know that I take the second term, 8 sine power 3 theta divided by 4 sine square theta. When you simplify, what do you get? You'll be having 2 sine theta. And this is your common ratio, okay? But I can't get the value for r and theta for now. Then let's continue and see what do we have, what do we get, or what do we have to form the second equation. And we are given this information. Sum to infinity is actually the half. If I write out, it will be sum to infinity equals to half. What's the formula for the sum to infinity? A over 1 minus r. What's the A? A is 4 sine square theta, right? So substitute it into the formula. 4 sine square theta divided by 1 minus r. So 1 minus 2 sine theta. So basically you can see that I'm trying to substitute the equation number 1 into my equation here. So 1 minus r equals to half. Okay, then I cross multiply this equation to get rid of the denominator here. And I'm having 8 sine square theta equals to 1 minus 2 sine theta. Group everything to one side. This is what I get. And let's continue and solve for the sine theta. How can we solve for the sine theta? We are having a quadratic equation, right, in terms of sine theta. Then let's solve it. We will be having 4 sine theta. Then this is 2 sine theta. Then 1 and 1. So I want to have positive 2. So positive 4, then minus 2. From here, continue to solve the equation. I'm having sine theta equals to 1 over 4. Then I'm having sine theta equals to negative half. Okay, then to continue, right? Basically, I only accept the answer for this equation, but I ignore the answer for this part. Why do I ignore the answer for this part? It is because of we are having sine with a negative value, right? Sine with a negative value, the answer of the theta should be in the third or also the fourth quadrant. Right? Negative one, negative sign will be the answer. The theta should be in the third or the fourth quadrant because third and fourth quadrant sign are negative. Third quadrant tangent is positive. Fourth quadrant cos is positive. Okay, so when we are having the sine theta equals to a negative value, your answer must be always in the third or fourth quadrant. If you have a look for the theta here, you can see that the theta is between 0 until pi over 6, which means that the theta should be in the first quadrant at least, right? That's a reason why I ignore this one. So we ignore this part. How can we continue and solve this one? So to get the theta, you have to take sine inverse, then 1 over 4. And I think this is your answer already because they want us to keep our answer in the pattern of sine inverse k, right? And k is a rational number, which is true because our k here is 1 over 4. Right? Yeah, so this is how we solve question number 2. Question number 3. Given that we are having this and it is equals to 12, find the value of the constant a. Alright, so this is an integration question. We just need to learn how to integrate it, yeah? Okay, then for first part, I try to keep my expression into the pattern of a bracket with the power. Okay, so I'm having the bracket upwards, bring the bracket up, become the numerator, so the power will become a negative, right? Then plus 2. Okay, so let's try to integrate the term. I'm having a as is a constant, so I just try to copy it. I focus on the integration of this bracket with a power negative 2. When you're having this pattern with a power negative 2, the integration is you will need to plus 1. You need to take the power plus 1. So negative 2 plus 1 become negative 1. And you need to divide by the new power. Then differentiate the thing inside the bracket. Differentiate 4x minus 3, you will get 4. Okay, so you have to divide your expression by 4. Then next term, integrate 2, you get 2x. And let's substitute the value of 3 and also the 1. And it is equals to 12. Okay, for me personally, I prefer to rephrase my my equation or expression first before I substitute the value, because I feel that this will make our expression doesn't look so complicated. If I didn't simplify, then later I feel like there are many negative here and there, then very easily I will make a careless mistake. Okay, so I simplify my expression first, then only I start to put in the value. Alright, okay, put in the 3 into the x here. So 4 times 3 is a 12. 12 minus 3 is a 9. So you're having negative a divided by 4 times 9. So 4 times 9, you should be getting 36, right? Okay, so you're having 4 times 9, which is 36. Substitute 3 inside the x here, 2x, you'll be having the 6. Then minus, now we want to substitute the 1. Substitute the 1 into the x. 4 times 1 is a 4, 4 minus 3 is a 1, so you're having negative a over 4. Then substitute 1 inside, you'll be having a 2. Then equals to 12. Okay, then now expand all the bracket. Negative multiply in become a positive a over 4. Then negative 2 equals to 12. Alright, so I just try to keep all my a on one side and I simplify them. I'll be having 2 over 9a. Negative 1 over 36 apple plus 1 over 4 apple. A is like apple, right? So negative 1 over 36 plus 1 over 4. I think you will get the 2 over 9. Move all the number to the other side. You'll get an 8. Then continue one more step. You'll get the value of the a, which is 36. Right, yeah, so this is how we solve the question number 3. Alright, so question number 4. Find the first 3 terms in the expansion of this in ascending power of the x. Okay, we are having binomial expansion. What's a general term or general formula to expand a bracket with a power n? And of course, the n that is in our syllabus will be the positive integer for AS syllabus. Right, the general formula will be NCR. Then we are having a power n minus r, b power r. Okay, so let's apply this formula into our question. We are having 2 minus 3x over 2 power 5. If I want to have the first term, I should have the r equals to 0 first. So first term is r equals to 0. So apply the n is the 5 in our question here. So I'm having first term is 5c0. A is the 2. So a power 5. 5 minus 0 is a 5, right? Then b power 0. So this is my first term. Plus, now I want to get second term. It will be increase 1 at the r. So I'm having 5c1, 2 power 4, then negative 3 over 2 power 1. Plus, the next one will be 5c2. Third term will be the 5c2. So 2 power 3 and also negative 3x over 2 power 2. Alright, so you can see that these are the first 3 terms. So we should stop here because the question asking for the first 3 terms only, right? Okay, but you have to remember, yeah, the first term start with 0, yeah, so NC0. Okay, then after that, you just use calculator and help you to simplify your expression a little bit. So by right, you should have 32 minus 120x, then plus 120 plus 180x squared. This is the first 3 term for this binomial expansion. Alright, then part B. Now they say use your answer in part A with a suitable value of x. Find an approximation of 1.985. 1.985 power 5. And this question, they already give you a very obvious hint. Yeah? You need to use your answer in part A. So we are trying to link the value here, 1.985 power 5, with what I have in the part A. Okay, so they are asking for 1.985 power 5, right? if you try to compare this one, yeah, you're having both power 5 outside, then you can direct compare. The 1.985 should be equals to 2 minus 3x over 2. Agree? So I need to know, yeah, what is the value of x, so that when I substitute it, I will get a 1.985 in the binomial expansion. So we try to figure it out, okay? Then we will let 1.985 equals to the expression that we have in our bracket. Okay, then if you try to solve it by right, bring the 3x over 2 to one side, you'll be having 3 over 200. Then further simplify, you'll be having x equals to 1 over 100. Okay, that means if I want to find out the value for 1.985 power 5, I try to use the binomial expansion that I get just now, because if I have this particular term with a power 5, after I expand the first 3 terms, I will get this. So same thing happened here. To get the value for 1.985, we already know that we need to put in the value x equals to 1 over 100. So we'll put it into this expression. Alright, so let's continue from here. You'll be having 32 minus 120. Then the x, I have to replace it by using 1 over 100. Okay, then plus 180 x squared. So the x also, you need to replace it by 1 over 100. Then you put a square. And use calculator to help you and simplify the value. By right, you'll be getting 30.818. Then don't forget that our answer, basically, we want to keep it into 3 significant figure. So I will basically change it become 30.8. Yeah, so this is how we solve question number 5. They want us to solve this equation, and given that the data is between negative 180 to positive 180, right? Okay, to solve any triple equation, usually for me, I will try to think whether is it possible for me to change my equation with only one type of trigo function. So as example, for this equation, right, I'm having 3 different trigo: sine, tangent, and cos. And for now, I will try to reduce the number of the trigo that appear here. So either I want to change everything become sine, or I want to change everything become cos, or I want to change everything become tangent. Alright? Okay, so first step, I think it should be easier if I try to change the tangent become sine over cos. Equals to 1 plus 5 cos theta. Oh yeah, before I forget, right? Usually for the trigonometry part, there are a few identity that we use it very often. So this one is like you have to apply some identity to change all your equation become a single trigo. There are 2 types of identity in our AS syllabus that we are using it very frequently. The first one will be tangent. Tangent theta equals to sine over cos. Then another one will be the sine square plus cos square equals to 1. Alright, so from here you can see that for the first step, I'm trying to substitute or replace the tangent theta by using sine over cos first. Okay, then if you have a look for my equation here, you realize that, oh, okay, there's no more tangent. In my whole equation here, I only have sine and cos. So we reduce one type of trigo function in the equation already, right? Okay, we try to simplify it first. To get rid of the cos theta, I will multiply it to the right hand side, bring it up to the right hand side. Then simplify it, I will be having 4 sine theta multiplied with sine theta can be written as sine square theta. Multiply the cos to the right hand side, I'll be having cos theta plus 5 cos square theta. Okay, so if you have a look for this equation now, I'm having 2 types of function trigo only. The first one is the cos and another one is the sine. And how can I change the sine or cos become everything sine or everything cos? So I think we can do it by using this one. Sine square, I can replace the sine square by using this identity, make it become 1 minus cos square theta. So I try to substitute it. I will be substituting sine square equals to 1 minus cos square theta. Then equals to cos theta plus 5 cos theta. 5 cos square theta. And simplify it. What do I have here is we'll be having 9 cos square theta plus cos minus 4 equals to 0. Yeah, so we successfully changed the whole equation, become only one type of trigo function, which is the cos. Right? And if you have a look for the equation here, it is basically the quadratic equation in terms of cos. How can we solve the quadratic equation? You can use factorization, or you can try to use the quadratic formula. You can try to attempt, you can try out. So this one, right, after I try, I realized that it cannot be factorized. What am I going to do now is I had to apply the quadratic formula. To solve for the value of theta, I have to use the quadratic formula where the formula is, okay, so let's recall quadratic. What is the formula, yeah? So to get the value for x, you are having negative b plus minus b squared minus 4ac, then divided by 2a. Okay, then let us continue from here. We are having cos theta is your x. Okay, negative b. B means coefficient of the cos theta. Coefficient of cos theta here is the 1. So negative 1 plus minus square root b square. B square means 1 square minus 4. A is the coefficient of cos square, which is a 9. C is a constant term. So you're having a negative 4 here. Then divided by 2a. So divided by 2 and then a. Right? If you further to simplify your answer, you get two answers here. The first answer is cos theta equals to negative 1 plus square root 145 divided by 18. Second equation, you will get cos theta equals to negative 1 minus square root 145 divided by 18. Okay, so we try to solve them separately, okay, for these two equations. Right, try to press calculator and see what is the value for this one. If you didn't do any careless mistake, by right, this value is a positive value that is smaller than 1. Okay, so to solve this question, we can take basic angle. After you get the basic angle, you need to go through the quadrant and see which is the answer that is in the quadrant that you want to accept. Okay, then maybe we go through again the question. Let us have a look. What is the quadrant that they are interested or they want us to find out? It is this one. Data from negative 180 to positive 180. That means you need to consider the negative angle from 0 to negative 180. Then the positive angle is 0 to positive 180. And this negative angle, right, 0 to negative 180, basically it is the third and the fourth quadrant. Then for this part, positive angle 0 to 180, it will be the first and also the second quadrant. Alright, and later when I want to go through the quadrant and find out the value for theta, usually I will refer to the quadrant diagram here. So first quadrant, everything is positive. Second quadrant, sine is positive. Third quadrant, tangent positive. Fourth quadrant, cos is positive, right? When I want to get the answer for the first quadrant, it will be theta. For the second quadrant, you need to take 180 minus theta. And please take note that all the theta here means the acute angle or the basic angle that we find out. Okay? Then for third and fourth quadrant, right? Because of in our question, they requested for negative angle. So for third and fourth quadrant, we have to write out the negative angle formula. So in the fourth quadrant, your answer should be negative basic angle. Then in the third quadrant, your answer should be negative 180 minus the basic angle. Okay, so this one might be a bit troublesome. Maybe for some of you feel that, oh, okay, this is so troublesome, I don't want to use this one. So you can use other method that you learned before and try to figure out the answer. But for me, this is what I always use. Right. So first of all, excuse me, let us figure out the basic angle for this equation first. Please press calculator, yeah? Please press calculator and check what is the answer for this one. This is a value, positive value that is less than 1. So you press cos inverse, you'll get a basic angle 52.2. Okay, then now I want to go through the quadrant and look for the answer of the data that we have. we are having cost with a positive value. Cost positive, yeah? Okay, then you go through the quadrant. In this quadrant, is it cost positive? Yes. So I want to accept the answer from here. How to get the answer from this part? It is basically the theta, which is a basic angle. So we are having 52.2. Okay, second quadrant, is it cost positive? No. So I reject the answer from this part. Third quadrant, is it cost positive? Also no. Fourth quadrant, is it cost positive? Yes. So I want to accept the answer from here. So to accept the answer from here, you should take negative basic angle. So it should be negative 52.2. Right, so I have go through the quadrant that we are interested. So I think you should stop here. Then let's continue to the other equation. Cos theta equals to this value. If you try to press calculator, right, this value should be a negative value, but it is also less than 1. Therefore, to get the basic angle, please ignore the negative sign and you take cos inverse the positive value of this one. And the basic angle should be 43.6. What is the reason that we need to ignore the negative sign? Because we want to make sure our basic angle is coming from the first quadrant. Therefore, the negative sign we always ignore it when finding out the basic angle. Right? Okay. Then now I need to go through the quadrant to find out the answer for theta. We are looking for cos negative. Alright. So which is the quadrant that will give you cos negative value? First quadrant, is it cos negative? No. So we don't take the answer from this part. Second quadrant, is it cos negative? Yes, right? So you take 180 minus the basic angle. So take 180 minus 43.6. By right, you'll be having the 136.4. Quadrant, is it cos negative? Yes, also, right? So you take 180 minus the basic angle, then you put the negative in front. So it should be negative 136.4. Fourth quadrant, is it cos negative? No. So you don't accept the answer from this part. And we have go through the quadrants. So I think this is the final part of our solution here for this question number 5. And usually I prefer to rewrite all my answer again from smallest value to the largest value. So I'm having this 4 answer for theta. Okay, then just a small reminder here. When you are trying to put your answer in angle in degree, this is in degree, right? Please make sure that you put it in 1 decimal place. Alright. Yeah, so this is how we solve question number 5. Question number 6. We are having an arithmetic progression. First term is A, common difference is a 2. N term is 55, and the sum of the first 3 n terms is 5760. Find the value of n and also the A. Alright, then now, we are having arithmetic progression. The general formula that we are using frequently in this part is the n term formula. When you are having the n term, what is the formula for n term? So it should be A plus n minus 1d. Okay, then what about the sum of the n term, first n term? It will be n over 2, 2a plus n minus 1d. And again, all this formula will be provided in the formula booklet if you can't remember it. Right? Okay, then now let's start with our detail here. I'm having the first term a, don't know the value. I know the common difference is 2. So this is our d. Okay, now they say the n term is 55. They're talking about the n term. So n term is a capital letter n, yeah? So you substitute it with capital letter n, and you let it equals to 55. And I want to put this by using my formula here, n term formula. So the n term formula will be a plus n minus 1d. And you put it as a capital letter n, then minus 1. What is the value of the d here? It is a 2, equals to 55. Okay, then I will make it like this. A equals to 55 minus 2n minus 2. So I'm having a equals to 53 minus 2n. And this is my first equation. Okay, because I'm having 2 unknown here, a and also the n. Alright, to get the value for a and n, I need the second equation. And please look for the information from the question. to get the second equation. So where is the information that I can get? Then now, we are looking for this one. The sum of the first 3 n terms is this one, which means that they give us the information where the sum of the 3n is equals to 5760. So we want to apply it in this formula here. Our n now become the 3n, and the n is the capital letter N, okay? So I'm having n over 2, so 3n over 2, 2a plus n minus 1d. So the n you change it become 3n, capital letter, then minus 1. The value of d that we know is a 2, right? And it is equal to 5760. Then I try to simplify it. I want to get rid of the denominator 2. I bring it over and multiply it with 5760. So by right, you will be seeing 11520. Okay, and after that, I'm having 2a. To solve this equation, of course, I have to solve the equation simultaneously. So from here, you can see that I can substitute my first equation into the second part here now. So a is actually 53 minus 2n. Okay, so this is 2a lah. Then plus this. Maybe I put it wider first. Okay, so 2 times 3n, you are getting 6n minus 2. Then equals to 11520. Okay, so from this part, from here to here, basically you sub 1 into this part here, the equation here. Okay, then continue further and simplify your answer. Simplify all the term inside first. Okay, so by right, if you simplify everything here inside, by right, you will get 112 plus 2n. Okay, then continue and expand everything. By right, you will get n squared plus 56n minus 1920. Okay, when you try to expand everything and then you try to simplify, right, then from there you will see that eventually you get a quadratic equation in terms of the n. So we try to solve it by using the quadratic method. For this equation, basically we can factorize it, right? So you will have 24 and also 80. Then you are having a plus here and minus here. From here, you can get two values of the n, where n is equals to 24 and also n equals to negative 80. But basically, we'll ignore this answer because of n is the number of the term, right? So in an arithmetic progression, we can't have a negative term. We usually have a positive term only, right? Okay, I'm having n equals to 24. And after that, we will want to find out the value of a as well, right? So here, this is part of our answer already. N equals to 24. Then let's continue further and find the a. How can you find the a? Substitute it back into the first equation. So a equals to 53 minus 2n. Then what is the value of the a that you get? I think you will get a 9. Right, yeah, so this is how we get the value for n and also the a by solving simultaneous equation. Alright, so question number 7. We are given the curve with the information of dy dx equals to this equation. Right, so find the set of value of x when y decreases as x increases. When you are talking about y decreases when x is increased, that means the function is decreasing. Function is decreasing. So when do we have the function decreasing? When our function is decreasing, right, basically you should know that the gradient of the tangent are decreasing as well because function decreasing. So your gradient of tangent is always having a negative gradient. Alright, which also means that the gradient of tangent, dy dx should be negative, which is smaller than 0. Okay, so this is how we can try to start to settle the question, right? So you can see function decreasing. So that means your dy dx, which is the gradient of tangent, should be a negative value. Therefore, we put it as smaller than 0. Okay, and let's continue from here. I want to have dy dx smaller than 0. So what's my dy dx here? It is 3x squared plus 10x minus 8. There are many ways for you to solve this quadratic inequality. So for me, usually I will try to find the critical value, then draw the number line. Okay, to find the critical value, I will just try to factorize them. And after that, I get the critical value here. I'm having x equals to 2 over 3 and also x equals to negative 4. This is what we call as a critical value. And I want to decide between what value of the x, what is the value of the x now when I put in, so that this inequality is a true one. That means I want to have this quadratic expression smaller than 0. For me, I'm drawing number line. Some students will want to draw the U-shape or N-shape curve of a quadratic, also can. Alright, or some students might want to use the table of sign, also can. Okay, where you try to draw a table out and then you see what is the sign, is it positive sign or negative sign? Then from there you continue to decide the set of value of x. So for me, usually I will use number line. Okay, then to make this bracket, the bracket of 3x minus 2 positive, my value of x must be more than 2 over 3. To make the bracket x plus 4 positive, my value of x must be more than negative 4. So all the places with the arrow here will be having a positive sign. So positive bracket multiply positive bracket, you also have positive overall. Then positive, negative, then this is negative. Then this one is no line, right? So negative and negative, it will become positive. Okay, and for this question, we are looking for the quadratic inequality which is smaller than 0. Smaller than 0 means looking for the overall sign here at the bottom, it must be negative sign. So the negative sign is here, which also tells you that the value of the x should be from negative 4 until 2 over 3. Alright, so which also means that if you put any value for x that's between negative 4 until 2 over 3, right, into this expression, you will get a negative value. That's the meaning. Right? Okay, then let's continue further. For part number B, it is given that the maximum point of the curve is and has a y coordinate of 27. Find the equation of the curve. Alright, then again, when you look at the keyword maximum point, which is about the stationary point, to find out the maximum or minimum point or stationary point, basically we will need to let dy dx equals to 0. Okay, when you let dy dx equals to 0, you will get the value of the x. Okay, so for this case, actually I can directly write out the value for the x here. I'm having x equals to 2 over 3 and also x equals to negative 4. Okay, alright. So now I want to know, I have a maximum point of the curve and it is y equals to 27, right? But my problem now is I want to know which coordinate of the x here will give me the y coordinate of 27. Okay, so if you want to double check which is the x that match the coordinate y, which is equals to 27, maybe you have to try and error a little bit, where you substitute x equals to 2 over 3 into the equation, okay, of the y. Oh, but you don't know what is the y yet, right? Sorry. So you don't know what is the y yet because we want to find the equation of the curve. So what can we do is that we try to determine it by using the d square y dx squared, if you want to decide, alright? Okay, so if you want to decide which one is the maximum point, you find out the d square y dx squared first. Continue to differentiate this expression, you will be having 6x plus 10. Okay, then you try and see at the point of x equals to 2 over 3, what is the value of your dy dx? Oh, sorry, what is the value of your d square y dx squared? So you're having a 14, if I'm not mistaken. It is greater than 0. So greater than 0 means that this is a minimum point. Okay, then at x equals to negative 4, if you substitute inside,
Your d square y dx square will be 6, and then multiply with -4, then plus 10. By right, you'll be having -14, which is a value negative smaller than 0. And when you're having d square y dx square smaller than 0, that means this is a maximum point. So from here, you know that the maximum point is having the coordinate of -4 and also 27. Right, so after you find the coordinate for the maximum point, we can use this later to find out the constant term in the equation. To get the equation of the curve, of course, you need to decide the y. How to get the y from dy dx? You have to apply integration. So we try to integrate it where I'm having 3x squared plus 10x minus 8. Okay, so try to integrate it slowly. So 3 is a constant, you just copy it first. Then integrate x power 2. X power 3, power plus 1 become a 3. Divided by the new power, 3. So 3 divided by 3, you get x power 3 here. Then simply happen for 10x squared. Integrate 10x squared, 10 is a constant, you just copy. X power 1 plus 1. That means the power plus 1 become x power 2 divided by the new power 2. Then divided by 2, you have a 5. So you're having 5x squared. Then minus 8x. Okay, then after that, I'm having a plus c here. And now I have to decide what's the value for the c. So to decide the value of the c, I have to use a passing point on the curve, which is the maximum point here that we found out just now. Substitute y equals to 27. Substitute the x as -4. So from here, if you try to simplify this equation, by right, the value of c that you get should be -21. So rewrite our equation one more time with the value of the constant. So you're having x power 3 plus 5x squared minus 8x, then minus 21. And this is our equation for the y. Alright, yeah. Okay, and then let us talk about the maximum point. So like what we know just now, we are having the maximum y coordinate is 27. So for me to decide which is the value of x that pair with it 27, I apply this square y dx square. Okay, but basically, according to one of my students, right, what he did is like, he realized that just now in part number 1, I'm having decreasing function, okay, decreasing function for the x between -4 until 2/3. Actually, it also means that -4, when x equals to -4, it is a stationary point. 2/3, it is also a stationary point. And because of after the x equals to -4, right, the function is decreasing. That means he suspect that the -4, x equals to -4, okay, is the maximum point, so that the function will decrease until 2/3, where x equals to 2/3 is another stationary point, and it should be a negative value, because it should be a minimum point. Because after the 2/3, right, you can see that our function is increasing. So after this stationary point at the lower part, the lower point, lower value of y, then the function will increase. Okay, so from the number line that he drew in part A, he know that the maximum point should be with the x coordinate of -4. So this is another way of deciding which is the value of x that pair together with 27. If you found that it is a bit too hard for you to understand this, then no worry, you can just directly continue by deciding it using the d square by dx square. Because some students might want to skip this step because of they know that according to what we have in the inequality on top, the -4 should be a maximum value. Then the 2/3 should be the minimum point. All right, yeah. Okay, so this is how we solve this question number 8. Oh, sorry, this is question number 7. Question number 8. We are given a diagram again. Then there's a square. There's a square ABCD. The every side is length 12 cm. The point E and F lies on the side BC. We are having E and F here. They are on the side BC and CD respectively. And BE is equals to 1/3 of BC. Okay, then DF is 1/3 of DC. So from here, right, if let's say the whole length here is 12 cm, BC should be 12 cm. And BE is 1/3 of BC. That means if this whole thing is a 12, 1/3 of 12 here will be the length of 4. So this one will be 8 cm. Same thing happen here. EF is 1/3 of the DC. DF is the 1 of DC, so this is a 4 cm and this is 8 cm. This is some information that we already can get from the question. Then EF, the arc EF is a part of a circle with the center A. Alright, the shaded region is bounded by the arc EF and also the line segment EC and FC. Okay, first question, they want us to show that the size of the angle EAF means this particular angle here. I try to label it by using theta. Is 0.9273 correct to 4 significant figure. Alright, so now for this question, if let's say I want to find the theta, there are actually many ways for us to find the theta. Alright, okay, for me, what I'm going to do is, because I found that I'm having two identical right angle triangle here, the triangle ADF and also the triangle ABE. These two blue color triangle here, they are identical, okay, because they're having the same hypotenuse, they're having the same length, adjacent length, also the opposite length, okay. Right, then therefore the angle for this part is also the same. For these two triangles is also the same for this part, right? I label this as alpha, this is also the alpha. Then to find the theta, what I'm going to do is I try to use a right angle 90 degree minus the 2 alpha here, then to get the theta. Alright, you might have some other way to find out. So this is one of the suggestions that I want to try now. Therefore, to get the theta, before I get the theta, I want to get the alpha first, right? So from here, if I look at this alpha, I know that the opposite length is a 4 and also the adjacent length is a 12. So from here, I can form a ratio for trigo, which is tangent alpha. So tangent alpha should be equals to 4 over 12. And my alpha will be tangent inverse 4 over 12, which is tangent inverse 1 over 3. Right, and like what I told you earlier is for tangent alpha, right? Yeah, so tangent alpha is 4 over 1 over 3. And after that, to get the theta, which is the angle FAE, or they are writing it as EAF, right? We are EAF. I have to take the 90 degree, the pi, minus 2 alpha. So 2 alpha means 2 times of tangent inverse 1 over 3. Okay, then from here you just try to press calculator, and of course you need to make sure that your calculator is in the radian mode. Okay, then you take pi over 2 minus 2 tangent inverse and so on. So you'll get a long list of value 0.927295218. Then we cut it short into the answer that they want. They want us to put our answer into 4 significant figure. So it should be 0.9273. Okay, so this is one of the way that you can use the triangle and also the right angle here to help you and get the answer for angle EAF. Then another method is, I did try another method before where I try to find out this one. Okay, the green color triangle, the angle here should be 45 degree, right? So 45 degree means pi over 4, then minus the alpha also can. Actually, they are the same. Okay, just that maybe the technique a little bit different only, but no matter how, we are always trying to use all the right angle triangle to help us. Okay, because you can get all the ratio, the angle from the right angle triangle here. Alright, so this is what we have for part A. Then let's have a look for part B. What do we want to find for part B? They want us to find the perimeter of the shaded region. Okay, so again, to make our to refer to the diagram easily, right? Easier, then I just write my answer here for part B. They're asking for perimeter. Alright, so what's the perimeter that we need to do here? So for perimeter, you need to consider the length of arc EF, then the length of FC, the length of EC. Length of FC and EC definitely no problem because you already know that the length is the 8. Our problem now is to find the arc length of EF. To find the arc length of EF, the formula is R theta. R is the radius, theta is the angle opposite here. So we have the theta already, right, just now, this one. Okay, and now we need to find the R. What is the R? The R is the radius of the circle. So the radius here, basically, the radius for the sector is the EF, AF or AA also can. How can I find this length of AF? So again, use the triangle to help us again. So remember the blue color triangle that we have in part 1 just now? The AF here basically is the hypotenuse length for the triangle here. So first step, let us try to find out the AF first. So by using the Pythagoras theorem, I know that it is actually 12 square minus 4 square. And by right, you'll be getting square root 160. So this is the radius of the sector. Okay, then after that, we want to find the perimeter. So how to find the perimeter again? So like what I told you just now, you are taking EC, which is 8 cm, plus FC, which is also 8 cm, then plus R theta. So the R is square root 160, and the theta here that we get just now is 0.9273. So you can substitute 0.9273 here. And after that, what do we have? Use calculator to help a little bit. By right, you'll be having a long list of answers lah. Then please cut it short into the standard answer, 3 significant figure. By right, you should have 27.7. Okay, so this is how we solve the part B for question number 8. Alright, then let's continue to next part. Part C, I think we still have part C, right? Okay, find the area of the shaded region. Right, so go back to the diagram again. To find out the area of the shaded region, how can we find it out? There are also many possible ways for us to find it out. Okay, so some students say that I use the half of the triangle minus the sector and triangle, then times 2 also can, right? Then for me, what am I going to do is I take the whole square minus the area of this triangle, the 2 triangle here, minus the sector, then I will get the shaded area. Okay, so this is what I'm going to do now. Alright, so I want to take the square, area of a square, I should write area of shaded region first way, yeah? Area of shaded region is equals to the square, area of a square, minus the 2 right angle triangle, which is the same triangle, okay, then minus the sector. Okay, so what's the area of a square? 12 cm times 12 cm, right? What is the area of the triangle here? So for triangle, it is right angle triangle, and we know the base is 4. For this one, the base is 4, the height is 12. So I'm taking half times base times height. Half times base times height. Okay, then minus the sector again. So what is the sector that we get just now? We already get the area of the sector just now, which is this one. So for me, I will put in the long value lah. Right, so the long value that I get here, I get just now is 27.729 blah 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 blah. Okay, then try to simplify it. Oh, sorry, not correct, right? Because just now we are not getting the we are getting the perimeter of the sector of the shaded area, but we are not getting the area of a sector. So sorry, I make a careless mistake here. Sorry. Right. So now let's come back to this sector. How to find the area for this sector? To find the area for this sector, basically it is general formula is half r square theta. You have the theta just now. I also have the radius just now, which is square root 160, right? So I think very easily also we can find out the area of the sector, alright? Okay, so I scroll down first. So just to remind you all, the formula for sector is half r square theta. Then this one is half times base times height. Okay, so come back to the sector. Half r squared theta means half. Your r is square root 160. Then you have to square it. And then the theta is 0.9273, right? We get the value in first part. It should be 9273. So I think this is the correct one. Then you try to use calculator to help and simplify all the term here. By right, you will be getting this. Okay, a fraction. If not, then you can change it become 3 significant figure, which is 21.8. Right? Yeah, so this is how we find out the shaded area for this diagram. Okay, question number 9. There are 3 points given, and all the coordinates are shown here. Where k is a constant, it is given that the angle PRQ is a right angle. Then show that one of the possible value of k is 10, then find the other possible value of the k. Okay, so first of all, we know that we are having a triangle, which is a right angle triangle. And we try to draw it out first. So if let's say I'm having 3 points that form a right angle triangle. Okay, so let's say this is a right angle triangle. Then they say PRQ is a right angle. So PRQ is a right angle. So this is how the triangle look like. And of course, my P coordinate is negative 13 and also 5. R is 2K. Then Q is basically 5 and 1. Okay, and what can we use? Is there any useful information that we can use to find out the value of K or not? So from here, I think the right angle is one of the important information. When we are having any right angle, right, you should know that the product of the gradient of the two lines should be equals to -1, right? Okay, then just to recall back again, do you still remember how we calculate the gradient from 2 points, for 2 points, right? Gradient of a line from 2 points. So you should use y1 minus y2 divided by x1 minus x2. Okay, then at the same time, for any right angle or the line that is 90 degrees to each other, you know that the gradient of line number 1, which is PR, multiply with the gradient of line number 2, which is RQ or QR, it should be equals to -1. Okay, by using the coordinate here, we try to form or find out the gradient of the line PR and RQ. So let's try out the PR. So for PR, I take y1, which is the P, minus y2, which is the K, divided by x1 minus x2. Then for RQ is the same thing. I take R1, y1, K minus 1 divided by 2 minus 5 and equals to -1. Okay, so for the numerator on top, I'm having 5 minus k and also k minus 1. Bring all the denominator go up. Okay, I'm having -15 multiplied with -3. Alright, then I try to expand it. If I try to expand it by right, I'm having 5k minus 5 minus k squared plus k equals to -45. Try to group everything to one side. Try and see whether you're able to get this quadratic equation or not in terms of k. So k squared equals to 6k minus 40. Okay, then how can we solve the quadratic equation here? Of course, we can factorize them. I'm having k and k here, then 4 and also 10, then -10 and also +4. And when we try to solve it, we'll have the value of k equals to 10. So we've successfully proved it up. And another value is k equals to -4. Right? This is how we solve 9a. And let's continue to 9b. For question number 9b, now they say that, okay, I'm using the k, which is equals to 10. Then there's a circle pass through the point P, Q, and R. If you try to imagine what do we have just now, right? This is our triangle P, Q, and R, right? So there's a circle pass through the point P, Q, and R. So that means the circle is something like this. My diagram might not be so nice, but you please try to imagine that this is a circle, okay? So there's a circle pass through the point P, Q, and R. It might look something like this. Okay, so this is P just now, right? This is the R and this is the Q. So PQR. Because they say PRQ is a right angle, if I'm not mistaken. Double check again. Yeah, PRQ is a right angle. So PRQ is a right angle, correct. When I'm having a circle that pass through the 3 points for this right angle triangle, they want us to find the equation of tangent to the circle at R. So where's the tangent to the circle at R? This is the tangent to the circle at the point R. Okay, and then now I want to find the equation of the tangent for this one. Okay, give your answer in the general form like this, where A, B, and C are integers. Alright, so now let's have a look. Yeah, how can we find out the equation of the tangent? To form the equation of tangent, I need two important information. The first one is the gradient that I need. I don't know the gradient yet. The other one is the passing point of the gradient. So of the line. So the passing point of the line I already have. The passing point will be the point R. Okay, and we already know that the point R, right, is having the coordinate, which is sorry, go back again. R is 2k. 2k means here they say k is 10, right? So R is 210. What is the P again? So P is negative 13.5. Negative 13.5 and then 5.1. Okay, so negative 13.5. And then this is 5.1. Okay, so we have the passing point. And now we need to get the gradient. How can we get the gradient for this tangent line? Okay, you have to use some properties that we learned earlier before, where first property is we are talking about when we are having a right angle triangle in a circle and the right angle touch the circumference of the circle, right? By right, you should know that the line PQ, the hypotenuse of the triangle, is basically the diameter. I believe that most of us learned it before, so you have to recall back and use this small concept here, okay, to find out the gradient. When you know that PQ is the diameter of the circle, right? So that means the center of the circle will be the midpoint of PQ. Okay, so I label the center as O. Alright, so from here you should know that the center of circle, which is the O, is equals to the midpoint of PQ, because PQ is the diameter of the circle. Alright, so midpoint of PQ. So that's the first thing that you need to know. How to find out the midpoint of PQ? So recall back, you take x plus x, so negative 13 plus 5, point P and point Q, and divided by 2. Y also the same thing, y plus 1 divided by 2. Then you'll be having negative 4 and also 3. Your center of the circle is negative 4 and 3. And why do we need the center here? Because I know that if I draw a line from center to the point of the tangent, yeah, okay, on the circle, they are 90 degrees to each other. So OR and also multiply with the OR and also the tangent line is actually 90 degrees to each other. So from here, I will know that the multiplication of gradient OR, the OR and also the gradient of tangent should be equals to negative 1. And before that, let us calculate the gradient of OR first. So what's the gradient of OR? You know the center is negative 4 and 3, right? And the R is 2 and 10. So the gradient will be, I take R first, so 10 minus the center, y coordinate of center, 10 minus 3 divided by, this is a 2, so 2 minus negative 4. Okay, so what is this gradient that you get here? The gradient that you get here should be 10 minus 3 is a 7 over 6. And of course, we know that the multiplication of gradient of OR and also the gradient of tangent should be equals to negative 1. Why? Because they are perpendicular to each other. So I know that 7 over 6 multiplied with the gradient of tangent is equals to negative 1. So from here, what is the tangent of the gradient of the tangent? It should be equals to negative 6 over 7. Okay, so here I have the gradient of the tangent. I have the passing point, which is the arc 2 and 10. And using these two information, we can form the equation of tangent. So equation of tangent, what is the general formula, yeah? So we are having y minus y1. So what is the y1? Your r, the y coordinate of the r, which is a 10. Okay, equals to gradient m. So m is negative 6 over 7. Then x minus x1, which is a 2. Okay, try to expand your equation slowly. Multiply 7 to get rid of the denominator and simplify your answer into a general form. So by right, this is what you should get. So you should put it in this general form because the question requested for it just now. Okay, yeah, so this is how we solve question number 9. Alright, so we are going to discuss question number 10 now. There's a curve C has this equation. And then find the coordinate of the two stationary points. So what is the steps that we need to go through when they want us to find the stationary point? So first of all, you have to find out the dy dx. Then after that, you have to let dy dx equals to 0. And you find the x. After you find the x coordinate, then basically you can find the y coordinate as well, right? Okay, so let's start. I'm having y equals to 9. I put it into the power form, yeah? So 2x minus 5, bring up the bracket, it will become power negative 1. Then plus 2x minus 5. Okay, so first, let us try to find out the dy dx first. 9 is a constant, I just copy it. I differentiate the bracket with power negative 1. When you do the differentiation, power you put in front, copy the bracket, power minus 1 become negative 2. You differentiate the thing inside the bracket here, differentiate 2x minus 5. You have a 2, right? Okay, then after that, differentiate the next term. Differentiate 2x, you'll get a 2. Differentiate negative 5, you get a 0. So from here, I'll be having negative 9 times 2 is 18, then over 2x minus 5 square, then plus 2. Okay, to get the x coordinate for the stationary point, I need to let dy dx equals to 0. When I let it equals to 0, then my equation will become something like this, yeah? Equals to 2, equals to 2. And I feels like I want to continue and get the value for the x, right? So you try to group all the x one side, all the number to the other side. I'm having a 9. Then 2x minus 5 is equals to plus minus 3. Continue further, you'll be having x equals to 2 value. First value is 3 plus 5 divided by 2. Another value will be negative 3 plus 5 divided by 2. Okay, so from here, what is the value that you get? You'll get a 4 here, and also negative 3 plus 5 is a 2, so 2 divided by 2, you get 1. These two values of x are the stationary point, or the x coordinate for the stationary point. And of course, we need to find out the value of the y, right? Okay, so how to find the value of the y here? When x equals to 4, the value of the y will be, substitute your equation, your x value into the original equation. So 9 over 2 times 4 minus 5 power 1. Okay, then plus 2 times 4, then minus 5. Okay, so you try and see that when you simplify and everything, by right, if you didn't do any careless mistake, you should be getting a 6. So 4, 6 is one of the stationary point. After that, substitute x equals to 1 also. You'll be having y equals to 9. Then 2 times 1 minus 5. Plus 2 times 1 minus 5. Okay, so from here, if you try to simplify it by right, you will be having negative 6. So 1 and negative 6 will be the other stationary points. Okay, so this is how we find the stationary points for the curve. Alright, then let's continue to part B. For part B, find d square y dx square, hence determine the nature of each stationary point. Alright, let us differentiate it one more time, but before that, maybe I recopy again. What is the equation of dy dx that we have just now? So the equation of dy dx that we have just now is 2 minus 18, then 2x minus 5 power negative 2, right? Okay, then I want to differentiate for another time. So I'm taking d square y dx square over, d square y over dx square equals to, differentiate the 2, you will get a 0. Negative 18 is a constant you copy. When you want to do the differentiation power, you put in front, right? Become negative 2. Copy the bracket. Power minus 1 become negative 3. Then you differentiate the thing inside the bracket. Differentiate the 2x minus 5, you'll get a 2. So you put it a 2 here. Then you simplify again. So for this expression, if you simplify, you will be having 72 divided by 2x minus 5 power 3. This is my d square y dx square. But now I want to use it to decide which one is the maximum point, which one is the minimum point. Therefore, I substitute the x coordinate into my d square y dx square. First, I substitute x equals to 4 first. For d square y dx square, if I substitute x equals to 4, I'll be having 72 divided by 2x minus 5 power 3. So the x here you substitute by using the 4, right? So I'm having 2 times 4, which is 8. Okay? Then you get the value, which is 8 over 3. And it is greater than 0. When you're having d square y dx square greater than 0, basically you need to know that it is a minimum point. So 4, 6 is a minimum point. Okay, so we are done for the first point here. Then let's decide the second point. So for second point, again, you have to substitute x equals to 1 into your d square y dx square. Okay, so substitute inside. By right, you should be having 2 minus 5 power 3. And when you simplify, you should have negative 8 over 3, which is smaller than 0. So smaller than 0 means that this particular point here is a maximum point. Right, yeah, so this is how we decided. Okay, but of course, before you apply this question, right, before you find out this question, you need to remember the result where d square y dx square smaller than 0, then it means that you're having a minimum point. Then d square y dx square greater than 0, smaller than 0, then it should be a maximum point, right? Okay, then let's see what do we have in part C. Okay, so for part C, now they are saying that the curve C is transformed to the curve C1 using the translation, followed by reflection in the x-axis. State the coordinate of the maximum point of C1. Okay, from C, now you transform it becomes C1. You go through 2 types of transformation. The first one is the translation. The other one is the reflection in the x-axis. Then what is the maximum point of C1? Okay, so for this one, to find the maximum point, for C1, you need to maybe start from the original point first, then slowly you convert it into the maximum point of C1. But how can we do that? All right, I want you to take note about the reflection in x-axis. When we are talking the reflection in x-axis, right? Let's say, originally you are having a minimum point. When you reflect it through the x-axis, you will see that your minimum point will become a maximum point. So this is original minimum point. When you have the reflection in the x-axis, that means it is up-down reflection. When you try to reflect the graph up-down according through the x-axis, then you will see that your minimum point now will become a maximum point. Therefore, when they are asking for the maximum point of C1, this is after transformation one, right? So when you want to get the maximum point for the curve that's after the transformation, the original point that you need to refer to is actually the minimum point of the original curve. So please take note on this one, yeah? Okay. Therefore, to get the maximum point of C1, I will actually take the minimum point in the C, which is 4, 6. Alright, so I will start with the coordinate 4, 6 first. Okay, so this is a part that you need to be very, very careful because a lot of students, when they look at the keyword maximum point, so they thought that, okay, I want to get the maximum point coordinate, they directly refer to the maximum point in the original curve, which is wrong. Because the original curve, maximum point after the reflection will become minimum. Then the minimum point in the original curve will become maximum point after the reflection. So please take note on this one. Very, very important, okay? Right, so we are having 4, 6 here, which is the minimum point of the original curve. It goes through the translation with a vector of -3 and 7. Then how can I move our minimum point after the translation? So you just add them together. 4 minus 3, you get a 1. 6 plus 7, you get a 13. So after the translation, right, the minimum point will become this one. After that, they go through the reflection in the x-axis. Reflection in x-axis. Okay, so for the reflection in x-axis, right, you affect your y value. That means when you multiply negative to your y value, so x coordinate will not be affected. So 1 remain as a 1 for the x coordinate. For 13 is a y coordinate. When you have reflection, you have to multiply -1 to the y coordinate. Therefore, you'll be having -13 here. So this is basically the maximum point of the curve C1. Alright, yeah, so this is how I go through it. I would select the point that I know it will become a maximum point first, then only from there I slowly go through the transformation, then change the coordinate accordingly. Alright, then let's have a look for part number 2. Now they said find the equation of C1 in this form, where the A, B, C, D, E are integers. Alright, then now, so for me, first of all, I want to write out my original function in the original equation in the function term first. So I let fx equals to original equation 9 over 2x minus 5 plus 2x then minus 5 here. Okay, then now I will rewrite all my transformation in terms of the function. So the first transformation is translation in -3 and 7, right? So -3, when you put it into the function form, it should be inside the basic function, which become x plus 3. Then the -7, it is still outside. Okay, so it will become the, plus 7, sorry. The plus 7 in y, so it will be plus 7 outside the basic function. So after the translation, your function becomes something like this. So how can we write out my equation here? So you copy the 9, copy the 2, the x now replaced by the x plus 3. You can see that? So you have to replace the x by using x plus 3. Okay, then minus 5, just copy minus 5. Plus 2, just copy the plus 2. And the x here, again, replace the x by using x plus 3. Minus 5 is the original one, you just copy minus 5. And this is the whole function, right? Then after that, don't forget about the plus 7 outside the basic function. So outside the basic function, I plus 7 again. So this is after the translation, how my equation look like. But before that, I prefer to simplify it first before I continue. So I'm having 2x plus 6 minus 5. 2x plus 6 minus 5 plus 7. If you didn't do any careless mistake, your equation now is become 2x plus 1, 2x, then plus 8. Okay, then after that, I need to go through the second transformation where I need to have reflection in the x-axis. When we are having the reflection in the x-axis, means that we multiply the negative to the whole function. So very easy, you just multiply a negative to the whole function that you get just now. Okay, so multiply the negative into every single term here. You'll be having negative 9 over 2x plus 1 minus 2x, then minus 8. Yeah, so this will be basically your equation of C1 after the transformation apply on the C. Okay, yeah, so this is how we solve the question number 10.
Okay, we are now at the very last question for this paper. The function f is defined by this one. For x can be any real number, where a is a constant, and we are given also the function g, but they give us the inverse function for the g. Given that the range of f is this one, range of f. Alright, so find the possible values of a. Alright, so let's look for the function fx. When we have this kind of quadratic equation, if you found the range, usually for us, we'll try to complete the square, because when you complete the square, right, we'll know what is the vertex, the coordinate of the vertex of the function. Then from that, we will know that how to find out the value of a by using this minimum value lah, because they said the range is fx greater equals to negative 33, right? So for me, to solve this question, I will try to complete the square first. This is my original equation. Okay, so to complete the square, you need to plus something square and minus something square after the x, right? And what's the something that I should put here? You have to take the coefficient of the x and then you divide it by 2. So 4x divided by 2, you are having 2x. Oh, sorry, 2a. So 2a, then here also 2a. Alright. Then after the plus a, I just copy it back. Then to make it become a completing square form, you need to basically make the first 3 terms into a big bracket with x plus 2a inside and then the square is outside. Then minus negative 2a square, you will be having 4a square, then plus 8. Okay, so when you have been given the value that the range of f is having y greater equals to 33. What does it mean? Basically, this means that the minimum value is negative 33. Is negative 33. Okay, because when we are having the completing square form, right, basically it means that I'm having the coordinate of the vertex where x equals to negative 2a and also y equals to this value. Alright, then in the question they did tell us that my minimum, the range is greater equals to 33. According to the pattern that we have here, it should be a U shape for this quadratic equation. And then this value should be negative 2a lah. I don't know what's a lah, okay, but I just simply draw it out. And then the minimum value is negative 4a squared plus a. And this minimum value basically is the value of negative 33, because negative 33 is the lowest value also according to the range here, right? So we will let negative 4a squared plus a equals to negative 33. Then we try to solve the equation from here. Okay, try to factorize it. I'm having 3 here, then 11. Plus 11 minus 3. Yeah, okay. That equals to 0. So from here, you'll get a equals to negative 11 over 4. And also a equals to 3. Yeah, so this is how we solve the question number part A, okay, 11A. Then let's continue the part B. For part B, now they tell us that, I'm having this, FGG0 equals 96, then find out the value of A. And this is a composite function for G, right? A composite function for FGG, but before that, I need to have the function of the G first. For this question, we are only given the function of inverse G, and it is equals to cube root of 2x minus 4. Okay, to find out the G, you need to let y equals to the cube root of 2x minus 4. Okay, then you try to change your equation from y equals to something something x, become x equals to something something y. Right, so I take the cubic or power 3 for both sides. Then after that, I'll be having 1 over 2, then y cubed plus 4. So I rewrite again in terms of x, yeah. So I'm having the gx is basically equals to half, then x power 3, then plus 4. So this is my gx. And now let us try to figure out what's the value for fgg0. Okay, so for fgg0 equals to 96, right? So first of all, I want to substitute the 0 into my function g first. Okay, so fg, if I substitute 0 into the function g, it will look something like this, a half. Then 0 power 3 plus 4 equals to 96. And you try to simplify the value, you'll get 2. Okay, so fg2 equals to 96. Just simplify all the value here in the bracket. I'm substituting the 0 inside the g, right? Okay, after you get the 2, then again, I have to substitute the 2 inside my gx equation, where I will be having half, then 2 power 3 plus 4. You are putting the x become the 2, right? Then plus 4 equals to 96. Again, try to simplify the value at this part first. So 8 plus 4 is 12, right? 12 divided by 2, you're having the 6. And now you're having f6 equals to 96. And what does it mean? It means that you have to substitute the 6 into the function f. What is the function f that we have just now? So function f is this one. X squared plus 4ax plus a. X squared plus 4ax plus a. Yeah? Okay, so x squared means it will become 6 squared. Plus 4ax, so 4a, x will be the 6, then plus a. And it is equals to 96. So you can see that how am I going to put all the value inside the function that we have. Then you solve it slowly, step by step. Okay. So when you go until this part, right, basically you will be having this equation 36 plus 24a plus a equals to 96. Simplify the equation, then you will get the a very easily. So 25a equals to 60, and therefore your a will be equals to 12 over 5. Or maybe some students will want to put in the decimal form, then it will be 2.4. Yeah, so this is how we solve question number 11. And this is the end of the paper. Thank you very much for watching the video.